Hello everyone. So today we are going to work on IB Maths Standard Level Paper 1, which is the non-calculator paper for the Time Zone 1 for the May 2019 series. Alright, question 1. So this seems like a very straightforward Venn diagram question. So they were saying that there is a Venn diagram and then there's event A and event B, right? So they say that event A is 0.3. So remember, the way to do this is always draw the whole circle and then write 0.3 on there. This is the best way to do it because if you draw it on inside the diagram, it's quite hard to know whether you're talking about, like the whole circle or are you just talking about one part of the circle, right? So they ask you to find the value of P. Well, that's very straightforward, right? So you would say like 0.1 plus P equals to 0.3. And therefore, that's why P is just 0.2. So that's it. And once we got the answer, it's quite nice to just, cross it out and then write 0.2 here, right? Okay, and then they ask you to find the value of Q. Then again, it's very straightforward because now we have all of the regions, right? You know the blue 0.3 and you know like the rest of the outside is 0.4. So you can start adding things, right? So you can do 0.3 plus Q plus 0.4. Now that would include all of the region, right? So that has to be equals to 1. And that is very straightforward because they're just going to give you Q is therefore 0.3. Now part C, they ask you to find P of non-A and the union of B, right? So, I mean, this kind of notation you have to know, right? If A means A, which is 0.3, then A prime is going to be not A, right? So what you're looking for the fact that you're doing for A, well, probability of being not A, union with B. Well, how about actually let me sketch what it looks like for what does it mean by non-A, right? So look, if this is A, okay, if that's A, what's non-A is basically everything that's around it, okay? So that would be non-A, right? Let me just sketch it. That part would be the non-A. And then let me just sketch a B here as well, because you also know that B is this thing. Now, for now, I'm actually going to sketch the whole B, like that's the B, right? Yeah, that would be our B. Let me just draw B here. So that's a B, right? Now, if that's the case, you have to really understand the difference between intersect and union. Intersect will be the part which is overlapped. But I mean, we're doing union here. We'll talk about intersect actually later. Then if you think about the union is the region where both are okay, right? So if I use green, okay, so I need the part which is, okay, not A, right? Which is like take outside here. And at the same time, it's also okay if it is B, right? Because it's like A prime union B, right? That means B is also okay. So that is also tick. I don't know if it's clear enough. So that part here is also a tick. Then you might be thinking, what about the intersect region, like right in the middle? What about this part in the middle here, right? The fact is that is also okay because we are doing union. It's like it could either be B or A prime, even though in the middle this is not A prime, right? Because this is part of A, right? But because it is still B, it is still B. So okay, so that would also work because we're doing union, right? So therefore, the answer is very straightforward, which is everything except, let me use yellow for this one. It's everything except this yellow region here, right? That means you can simply do equals to 1 minus everything that's not yellow, which is 0.1, right? And therefore, that will be 0.9. That will be the answer. Another way you can do it simply completely mathematically without drawing anything is to actually use the thing that we've learned, right? You also know something like this, right? The probability of A prime union B equals to probability of A prime plus the probability of B minus the probability of A prime intersect B. This is also okay. But I mean, even if we go through this way, you still have to figure out what is that thing, right? So if anything, I would just suggest you to just draw it out, color it, and then, you know, show that as 0.9, right? But still, then actually think about what does it mean by the intersection of A prime and B. Even though that might not be part of the question, but for now, it's good to know, right? So in this case, how about let me just draw this again. So I'm going to draw the Venn diagram again. So look, they say, okay, let me just draw the same thing, right? So that's going to be A, that's going to be B, and then the outside region is again same old non-A, right? That's A prime, and of course B is going to be the region here. The thing is, if you're looking for intersection, it is not like union where either one is okay or both is okay. If we are talking about intersection, so for example, that intersect with B, we are looking for region where both have to work. So it has to include both region, which is the overlapping part. Then in that case, it could only be this region right here, okay? Because only like excluding the middle part is only this part, yeah, here, excluding that part in the middle. The reason why is because only in this case is the way that you have both being not A and B as well, right? You have to satisfy both conditions. Then in that case, that is basically Q, right? In that case. So sure, you can also go through the same route here, which is completely fine. But yeah, it's really up to you. All right, question 2. This is a 3D vector question involving vector equations of straight lines. Okay, so to be honest, these are very, very straightforward if you know what you're doing. But I would like to take some time to first explain what does it mean by a vector equation of a straight line, because I do think a lot of students could be struggling to understand why this is a straight line. Meaning the way that you see on your textbook is going to be something like this, right? R, a vector R equals to A plus mu B, and then a lot of students have no idea where the mu come from or what does it even mean, all right? So here I would like to make an analogy to point out that actually this way of writing a straight line is very analogous to actually your y equals to mx plus c. I mean, if you think about it, right, both of them represent a straight line. Well, a little bit of difference is just that like this one, y equals to mx plus c, is only a straight line in 2 dimensions because you only have x and y coordinates, right? You can do the same way if you just introduce another coordinate, which is the z coordinate, right? X, Y, z. So that is also fine. You can write your equation of a straight line that way. But of course, you can also do it using the vector notation. And of course, in this case, the vectors are three vectors, right? Are 3D vectors. That means the equation of the straight line is going to also be in 3 dimensions. All right, but then let's think about what's going on for now. Why is this analogous and how is that represent a straight line? Now, I'm trying to make the teaching part shorter because remember this video, I only want to focus on the solution to the question. But I do think it's very important to understand this kind of core concept before we start, okay? So first thing first, you have to understand what is meant by R and mu and A and B's, right? So R is actually a general point on the line, general point on the line, okay? Just like how in your y equals to mx plus c, the fact that y and x will contribute to a general point of the graph, right? X, Y, right? That's what it means, right? That means if you put X in, you know what the Y is, and like the X and Y's are things that you could sort of change, right? And to give a different point which is on the line. So in this case, since we are doing in vectors, turns out R itself is already sufficient enough to show where the point is, because you can just do a position vector of R. In that way, actually, this is actually OR, right? Like the vector OR. That means from the origin towards the point of the line, which is the position vector of a point R. And then actually, well, of course, that's a little bit more, right? Because if there were 2 parameters here, that means there's 2 as well. So actually R is a general point, and actually mu is the thing that you can change to get to a different general point. Like in here, like you can think about like with a different value of x, you get a different value of y, right? You get different points. In this case, actually, when you get a different value of mu, you'll get a different value of r, right? Then we have to think about what that line means, right? So I'm going to make a claim. Now that's going to be the origin. Now it's going to be 3D or 2D. It doesn't matter for now. I just want to illustrate my point. So let's say that is the origin. And of course, I am going to then need to have to draw a line. I'm going to have to draw a line here. So that's going to be a line. Now I'm going to skip the axis because it could be 2D, it could be 3D. It doesn't matter. Well, then let's go for a point R on the line. Let's say this is a point on the line, right? Like at this point, you can really imagine this point like sliding along the line, because remember the R point is a general point on the line, which means it just represents that like, okay, there's a point on the line. It could be anywhere on the line. It could slide along the line with different value. Later you will see with different value of mu, this point could go really anywhere on the line. And then of course, since we are doing vectors, we have to do something like this, because this is the vector from O to R, right? This is our position vector O to R, which of course is just R, the vector R, which is the one that we have. That's showing that it is a general point, right? Okay, so then I'm going to make the claim that I can first travel A. All right, I'm going to have an A. Now A, by the way, this case would actually be a point on the line. You might be thinking, wait, isn't that a general point? Well, no, this is not a general point. This is actually an exact point on the line. Well, let me just with actual numbers. Like it has to have, it's actually a point on the line. So it's a fixed point. I mean, that's what you learn, right? It's a fixed point. That means I can actually put a point here. This is the point A with an actual vector. Like it's an actual fixed point on here, right? So I can actually, if I want to, I can give it a number. Like that's 1, 2, 3. Let's say that's 1, 2, 3. Like there's an actual point on the line. So of course that's going to be vector A, which is, I mean, OA, right? That's basically OA, right? Which is actually just, you know, the vector A, right? The vector A is going to be that. So let me just put a colon here. Okay, so that's vector A. It's an actual point on the line, right? And then what does it mean by B? B is actually the direction vector. Direction vector on the line. What does it mean? It means it's going to be a vector direction which is parallel to the line. And since we are only caring about the direction of B, it really doesn't matter the like how long B is, right? B, I mean, theoretically the best is to use a unit vector for B. But it doesn't really matter, because the point that we want to focus on is that B has to carry the sort of like the direction. Like the thing that we care about is the direction that was carried by B, right? So, okay, then if that's the B, which is a direction of the line, then you can see what's going on, because if I want a general point R, now this is the claim, right? If I want a general point R, what I need to do is that I have to first, well, R would therefore equal, first I go to A, which is A, and then I would travel in the direction of B by, well, in that case, this line here would sort of represent by, you know, like some multiple of B, right? By doing different multiples of B, I can get to any point on the line. I mean, if yeah, that's why what we can do is then we can plus mu B, right? And you can see mu would therefore actually be a scalar that you put into the graph, so that by changing different mu's, you can get to a different point on the line, right? Because, I mean, if mu is negative, that it just go the other way. So you can go to like all points on the line. And that's how this equation looks like, right? And in this sort of analogous way, you can sort of see that if B is the direction of the line, that is sort of what it means by, you know, the slope of the line when you're mx plus c. Because by changing B, you would actually get a different line, right? I mean, on a different diagram, I can do something the same as well, right? If that's the origin O, if this time A, okay, if this time A is somewhere like here, if that's A, and then B is something that goes up, then I would have a line that looks like this. And that's B, right? Then I'll get a line that looks like this. Because this time I first travel A to here, and then by changing, well, by adding multiples of B's, I can slide along this line, right? And that would give me a different line. So in that case, B is sort of analogous to the gradient of the line, depending on like sort of what the orientation of the line is, right? And sure, therefore, actually A is in a way analogous to C. A is an actual point on the line, right? and C is the y-intercept of the line, which is also an actual point on the line. So I hope this give you a very rough introduction of what does it mean by a vector equation of straight lines. Okay. Now if we go back to here, then this question is quite straightforward, because if you look at part A, they asked you to find C, right? Now they gave you an equation of a line and then also a point P that lies on the line. So if you think about it, what does that mean? That means point P is going to be one of the actual points here, right? When you do y equals mx plus c, if you were given a coordinate, you simply plug it into the x and y and then you can solve it, right? But in this case, what you're plugging in is you're actually plugging into the r. Because remember, r is our general point. So that means you are looking for something that looks like this. So 15, 9, and c equal minus 3, 9, and 10 plus s, 6, 0, 2. Then what you're looking for is actually you're looking for what value of s would actually give you this point. Remember, that means I'll first travel 3, 9, and 10 to a point, and then I move a multiple of vectors with the direction of 6, 0, 2, right? Then I'm looking for what value of s would give me the point that I want, right? So that's what it is. I mean, of course, that point has to lie on the graph for that to work. Then, therefore, the way to do it is straightforward. Now, I hope you can see that this is actually going to be 3 equations, because you can basically find each equation for each component x and y and z, right? So that means if I use the first equation there, I could get something like 15 would therefore equal to minus 3 plus 6s, right? To be honest, you can't use the second equation because there's a 0 here. It just multiplies your s to 0, so you couldn't solve for s, right? So in that case, you could therefore just get s with a bit of calculation. S is 3, right? Or get s equals 3, right? In that case, that means we know that the value of 3 for s is going to give us the point that we want. Therefore, you look at the third equation, you can do c would therefore equal to 10 plus, s is 3 times 2, which is 16. So we got c 16, so that's done. Now part B, so they're saying that's L2, which is another line, is parallel to L1. Now remember, just go back to y equals mx plus c. If two lines are parallel, they have the same slope, right? So in that case, if you remember, the slope is analogous to the direction vector here. So if two lines are parallel, that simply tells you that the direction vector of both lines are the same. So in that case, you can write L2 is therefore a vector, okay? So that is a fixed point. Actually, you know it's going to be 1, 2, 3. Plus another constant, so usually I'll use lambda or mu. So let's do lambda of the direction vector has to be the same. Remember, yes, because both lines are parallel, so they need to have the same direction vector. Sure, and then of course, yeah, now that we already know it passed through 1, 2, 3, right? So that means, sure, this is the fixed point on the line, right? That means that actually, let me just sketch it out again, right? That means if you have a straight line right here, that's L2, and it goes through a point 1, 2, 3, so that's 1, 2, 3, okay? And what's happening is that what I'm trying to say is I can go from O to here, the origin to here, by the vector 1, 2, 3, and then afterwards I can travel a multiple of directions along this line, right? And because two lines are parallel, they should have the same direction vector. That's why I can write it like this, okay? Now, just one more thing. I mean, that would already give you the answer, but if you really want to, you can actually do 1, 2, 3 plus lambda of 3, 0, 1. You can sort of simplify, well, not simplify, okay? You can do multiples of that. Because remember, the whole point of this vector here, like this vector here, is just to show the direction. So it doesn't really matter if there's a different multiple or what, because that means lambda could just be a different number, and that would work. Okay, so if you really want to be rigorous, you change it to a mu, but it's the same thing, okay? But you don't need to do that. Like that, the red one would already be sufficient to get your mark. Question 3. The following diagram shows a right angle triangle, ABC, and then point D lies on AB, so that CD bisect ACB. So of course that's like theta and theta, and then you got AC is 14, so you write 14 here. Remember, once you work out a clue, or if you are given the clue, please write it onto a diagram. All right. Now, question A. Given that sine theta is 3 out of 5, find the value of cosine theta. Now, if you know your identities well, your trig identities well, you should know this straight away. This is like, this is like the first instinct that you do, right? That's one. Well, then it's quite easy, right? Then you can say cosine theta, therefore, is going to be square root 1 minus sine squared theta. Now, this you have to know by now. This is like very straightforward. So therefore, 1 minus 3 out of 5, like squared, over like square roots. And that's going to be 1 minus 9 out of 25 square roots. So that's going to be square root of 1 minus just 16 out of 25. So both of them are squared numbers. So it's just going to be 4 out of 5. So that is easy enough. But just so you know, if you see sine theta being 3 out of 5, surely, well, I mean, not surely, but like if you are like good with your numbers, you can see that that is a very famous Pythagorean triple. Meaning, I hope by now you need to know some triangles, right? For right angle triangles, you have to know if that's 3, 4, and that's 5, right? Like this is something you have to know, like the Pythagorean triple. 3, 4, 5. Another Pythagorean triple is 6, 8, and 10. And one more is 5, 12, and 13. Now, these Pythagorean triples, I mean, it's good to know in your head because like then you can click very, very easily. Because if you see cosine, well, sine theta is 3 out of 5, you can sort of, already see, okay, that means that's the Pythagorean triple of 3, 4, 5. So, cosine theta will have to be 4 out of 5. But remember, even though you know that, you still have to justify it. So maybe you can just draw the triangle out and then you use English. You say, okay, I know the Pythagorean triple of 3, 4, and 5. Therefore, I can know that cosine theta is 4 out of 5. As long as you justify it, like all of these are valid method. Part B. Find the value of cosine 2 theta. So easy work, really textbook work, really. So that is really cosine 2 theta is simply double angle formula. You can either use that minus sine squared theta, or you can use the 2 cosine squared theta minus 1 or 1 minus 2 sine squared theta. But it doesn't matter. So let me just use this one. So that's going to be 16 out of 25. Minus 9 out of 25, so it is just 7 out of 25. Then that's it. Now part C, hence or otherwise, find BC. Then you know if cosine 2 theta is that, and very straightforward, right? If that's BC, that's my 2 theta, then surely you are already doing cosine, right? Because then you just do cosine of 2 theta is just adjacent over hypotenuse. So 14 out of BC. So a little bit of math, BC is just 14 out of cosine 2 theta. That's 14 divided by 7 out of 25, right? And then of course you can flip it because you're doing fraction division, and then that would just give you 50. And of course add the unit, so cm, and that's really it. Question 4, you are given a function and then write down the equation of the vertical asymptote of the function f. By now you have to know an asymptote means like it's a line which the function couldn't cross. Then to be honest, for part A, they already gave you the answer. They already tell you that x couldn't cross -3. I mean, this is something you have to know, right? Even if they didn't give you that, you still have to be able to figure it out, because whenever you're dealing with a function with the unknown being in the denominator, like this, you always have to, well, be very alarming that therefore the denominator could be 0, and that could not be done because there are things in math you can't do, right? For example, you can't divide by 0, you cannot do tangent of 90 degrees, you cannot, for example, square root a negative unless you're doing complex or imaginary numbers. So these are the things, or you cannot log negative numbers, you cannot log 0. So these are the things that you have to know that you can't do in math, right? So whenever you see that like an unknown, the x here, it's in the denominator, you have to remind yourself that that means there is going to be some asymptotes in the graph for which x couldn't be the value such that the denominator being negative. So or being 0, sorry. Then that means you simply get x equals to -3. That would be the vertical asymptote, right? Now, if I were to actually sketch the graph, right? So let's see it. So if that is the graph, even though I do not know what it looks like, so that's y and that's x, I still have to know this line of x equals to -3 cannot be crossed because x couldn't be -3. Remember, if x is -3, you'll be dividing by 0, which can't happen, right? Okay, so part B. Find f minus 1 of x. So you find an inverse of the function f, right? To find the inverse, the way you do it, I think is very straightforward, just 2 steps, right? So first, you write it as y equals to 2x minus 1 over x plus 3. And then what you do is you simply, well, replace the x and y, right? So you write x and then like replacing it with y. So then you get x equals to 2y minus 1 and then like y plus 3. And then you simply make y the subject. Then the way to do it, I think is very straightforward. You get, you multiply over, so xy plus 3x equal to y minus 1. And then bring the y's together. I mean, it's really up to you. So you can get 3x plus 1 equals y, and then factorize 2 minus x. If you're struggling at this point, you can pause the video, have a think about why I did it, and then of course, a bit of rearranging. Y would therefore just be 3x plus 1 over 2 minus x. The reason why I moved the numbers like this is because I want to avoid as many negative signs as possible. That's why I decided to move the -1 over and this one here. So that is the inverse, right? Therefore, you can write f minus 1. That is going to be equal to 3x plus 1 over 2 minus x. Now, part C. So they ask you to find the equation of the horizontal asymptote of that, right? Of your function that, right? So that is your thingy. Let me just write it down again. So they are looking for the horizontal asymptote. What does it mean by horizontal asymptote? It means an output that we couldn't get. Because, okay, think about the question part A here, right? So part A, a vertical asymptote, meaning like here, is the fact that you cannot have x cannot be equal to -3, right? That's what we get when we are doing vertical asymptote. Because vertical asymptotes is really saying that the x value couldn't be a very specific number. Because remember, vertical lines are x equals to k, something like that, right? So vertical asymptote is actually to do with the input. It's a line where you cannot put your input as, right? If x can't be -3, then it will be a vertical asymptote. But the horizontal asymptote on the other hand, let me just sketch it here, right? If you have a horizontal asymptote, it would look something like this. Let me use black. It would look something like that. Let's say something like this, right? So that would be a number itself as well. What that really means is this time is not to do with anything that you couldn't put in. It's actually anything you couldn't get out. Because like if you think about it, y is my output, right? Y is output and x is input, right? X is input. Like when you have a vertical asymptote, you're doing like, oh, x can't be -3, so the input cannot be -3. But if you actually have a horizontal asymptote, it actually tells that y can't be a specific value. So actually your output cannot be a specific value. So how would you do this? I mean, you can figure it out from here, which is completely fine. However, since you already done part A and part B, maybe you can find some hints from there. Now remember about like functions, right? I think we've gone through this a lot of times. So if you have a function f, remember your f, right? You put some x in, you get some y out, right? And then just now we tell that we said that we cannot put -3. You cannot do that, right? That's one of the things we cannot do, right? Because like, we can't be divided by 0, and that is shown by the vertical asymptote, right? The fact that we cannot put a -3. However, now that we are dealing with f minus 1, it's a bit different because this time you're putting something in here, you get something out. Like the inverse function actually flipped input and outputs, right? So this time you're putting something in and you get the same thing out. So in that case, when you're dealing with f, you cannot put -3 in. Now that we've flipped it, that simply says that you cannot get -3 as your output. So cannot get -3 as my output. That means the horizontal asymptote is actually y equals to -3, right? It actually means that you cannot get -3 as your output because previously, when you think about the function itself, you couldn't put -3 in. Then now that you inversed it, now that your input becomes your output, that means you cannot output a -3. So therefore, the horizontal asymptote is actually just y equals to -3. Well, that means that line is actually like somewhere like down here, okay? But yeah, it doesn't matter. I just want to illustrate the point. Question 5. The derivative of a function f is given by blah, blah, blah. So the graph of f itself passed through a point, find f. Now, I think this should be very straightforward by now. This is obviously you're going to integrate it, right? Because like if they gave you that the derivative of f, that means you write this, right? If a dx of the function f, to tell you that that gives you 2e minus 3x. And to find f itself, surely you just integrate it, right? Because integration is like the reverse of differentiation, right? So the first thing you do, therefore, you can just write f itself, fx, okay, is simply just integrating that, okay, and dx, of course. And you will see why we need the a third and 5 later, because after you integrate it, you're gonna get an arbitrary constant, your plus c. Don't forget that. Now and then, therefore, you will need an extra point that you put in to find your c. Well, it will become like quite apparent later. So let's integrate this first. Right, how to integrate this? By now, like this is actually very straightforward. I hope you know this. You will do 2, like the 2 still stay, right? Like because actually, if I just do one more thing, right? Like the constant, if it's multiplying by a constant, the constant could go in and out of the integration. It doesn't matter. Like the 2 itself could go in and out of the integration. It does not matter, all right? Okay, now, well, I mean, sure, then you just get 2. And then integrating this, what you have is a minus a third, and then e to the power of minus 3x, and that's it, right? To do with why that's the case, maybe eventually we can do some integration, like, you know, help that I can talk more about integration, but for now let's focus on the integration part first. Then okay, so that is that, and of course it's going to be minus 2 out of 3 e to the minus 3x plus c. Right, and then we have to know how do you get plus c, right? Here is the fact that you have a point is where it kicks in, right? The fact that you have a point that lies on the function f simply tells you that if you put a third, you get a 5, right? That is what it means, right? That means you can simply do that and then you figure out your c. So then you can do like that, but therefore equals to -2/3 e to the power of minus 3, and then now x is a third, right? And then plus c equals to 5, and then that would actually give you c, which just simply equals to 5 plus 2/3 and a bunch of these. Now that's just e to the power of minus 1. Right, and then of course you can therefore simply, so that your fx is simply just minus 2/3 3x, and then plus c, right? You know your c, which is plus 5 plus 2 out of 3 e to the power of minus 1, and then you're done. So that's a very straightforward 5 marker if you just know your integration well. Okay. All right. Question 6. So this is another vector question. They gave you 2 vectors, u and v, with a magnitude of 4 and √3, right? And then they tell you that the angle between them is pi by 6. By now, you should be able to know that it's about 30 degrees, all right? So in that case, what we can do is, when they say magnitude, I hope you know what they mean, is they mean that the magnitude of u is 4 in that case, and also the magnitude of v is √3. And I hope by now you can probably guess what's going on here. Look, if they gave you the magnitude of, you know, like 2 vectors and then the angle between them, actually, if they just give you the angle between them, it should really click in your head that you're going to use the cosine thing, right? Either the cosine law or the cosine, well, the vector version of the cosine law, right? So we'll see how this question plays out. I'm pretty sure you're going to use it. I haven't even read the rest of the question, but I knew you're going to use it somewhere, because just because they gave you 2 vectors and like something to do with the angle between them. Right, so that now they gave you like w equals u minus v, so that's another vector. And then they ask for the magnitude of w. So to be honest, like right on top of my head, right, like you can't really imagine what's going on here. It's quite hard to imagine vectors, right? Therefore, you always draw it out, and then it will be a lot more clearer. So when it comes to drawing vectors, okay, like if they didn't specify what vector it is, you really just draw a random arrow, right? Like the thing I do is I would avoid drawing it completely vertically or horizontally, just because that could be misleading. Since it's a completely general vector, I pretty much just draw diagonally, sometimes like that. So that's going to be u. Let's say that's u. And you also know that the length is 4, right? So I can also write like 4, like bracket 4, right? That's also 4, right? Right, and then the angle between the other vector is pi by 6, which is 30 degrees because pi is 180, right? So 30 degrees, you really might want to draw something that looks like 30 degrees. So something like that. I guess that looks like 30 to me. So that's pi by 6. And of course, you're going to have a vector v, right? So that's vector v. And you also know the length is root 3, right? And that's another vector. The reason why I draw it like this is because they were given, you know, the angle between them, right? So surely you draw the two vectors like that so you can show the angle between them. Right, then we had to think about what does it mean by w equals to u minus v. Now, what does it mean by u minus v? So let's say w equals to u minus v. And by now, I hope you know what that means, right? U minus v means you first go along u, and then you go to the opposite direction of v. Right? Like v is going this way, right? So if you go to u this way, and then you go to minus v, that means like you're going backwards like that. Okay? That's your v, right? That's minus v, isn't it? Yeah? I think that makes a lot of sense, right? And then of course, since like this should have to be parallel because minus v is just the opposite way, right? It has to be parallel. So that is also pi by 6, right? And then they ask you for the magnitude of w. Then let me just draw w first, right? If that's minus v, then w is going to be from here. So that's going to be w. So that here, this is going to be w, right? Okay, now, you know, for this, you know, for like the clarity of the diagram, I'm going to write u on the other side here. And the, you know, the length is 4, we know that. And then that's a w, so I'm going to label it. So that's a w. And then by now, I think this is very, very clear what to do. It is exactly cosine law as expected, right? So, yeah, I mean, that's really it, right? So that's a w. The reason why that's w, remember, like if a vector is a combination, a linear combination, right? It means like just plus and minuses, right? Sort of. And then what you do is you simply follow along the route. And then, okay, you go u, and then a negative direction of v, and then a start point and the end point, right? Like that start, and that's the end point. And that will be the resultant vector. This is what we call the resultant. If you have learned physics, if you do a physics, then you should know there's a resultant vector, or you can call that the net vector, right? Like it means like the overall vector, yeah? And then that's quite obvious, right? Because that means you're not even looking for the vector w. You're just looking for the length of it. And that means actually we can just use the normal version of cosine law. So actually what I'm going to do is I'm going to actually draw this whole thing again, but using a bit simpler diagram. Because this time, since they're asking for the magnitude only, what I really need to do, I don't even need to care if they are vectors or not, because I can completely treat them as like a normal triangle. So let me just draw whatever that thing was, and then that is that. Also, there's a very important thing to know. This is not a right angle. That is not a right, I mean, it could be a right angle, I do not know. But when you draw it, it's best to avoid drawing such a nice thing, unless you are being told that it's a right angle, or you're told that like, oh, that was a complete horizontal line or a complete vertical line. Draw it sort of like as irregular as you can, so that you do not like just randomly assume it's going to be something like that, right? So yeah, but I mean, in that case, it doesn't really matter what the angle is, it doesn't matter. So then I am going to label that w, right? And then we know the length, right? That I know that's minus v, but if you're simply looking at the length of the line, it doesn't matter. It's still root 3. And then that's 4. And then you know that angle is pi by 6. So very straightforward. That's cosine law, right? As expected. Even though that is not the vector version of cosine law, it's still cosine law. So there's a different way you can write it. You can therefore write w squared equals root 3 squared plus 4 squared minus 2ab, right? 2 root 3 4 cos pi by 6. And then again, like special angles, what is pi by 6, right? You have to know these, right? So first thing first, okay, root 3 squared is just 3 plus that's 16 minus 8 root 3 cos 30. Okay, you have to know by now that's root 3 over 2, all right? And of course that's w squared And then w squared is therefore equal to 19 minus that's 3, and then that should be 12 because that's 3 times, yeah, that's 12, and then that's 7, and then therefore the magnitude of w equals, of course, is like that, right? Equals to root 7 because you've got to square root that, and then you're done. So it's a 7 marker. It seems very hard, but if you just draw your diagram, it is actually quite straightforward. All right, question 7. A particle P start from point O, the origin, and moved along a straight line. So you already know that's going to be a kinematics question, right? Yeah, so I mean, for kinematics question, it really depends whether you do physics or not. For those of you who actually do physics alongside your IB math, these are actually really straightforward questions because you'll be dealing with this for so long in physics already. But for those who don't, here I would suggest you, like, when you do this type of question, do not dive straight into the question. Whenever you got like a VT graph or a displacement time graph for practices, please understand what the graph means before you even start doing the question. Because like for those of you who do not do physics, sometimes kinematics could be quite confusing. But if you just understand what it means, what the diagram means, what is going on here, the questions usually are very simple, especially in the paper 1 question where you do not need to use a calculator. So okay, let's go. So right now you got a VT graph of a particle P, then move along a straight line, and then it's shown for the 0th second, the first 6 seconds basically of the motion, right? And then it tells you that there's intercept at 0, 2, and 4, and then of course the function st is the displacement function of the particle after t second. And then you're given some information that, P traveled a distance of 15 meters in the first 2 seconds. Also, S2 equals to S5, meaning the displacement at 2 and displacement in the 5th second is exactly the same. Of course, you have an integral of V blah, blah, blah equals to 9. So again, let's start to understand what that graph means first, okay? So if it's moving on a straight line, what I can do is I can actually just draw like a line like this. Give me a second. So what I can do is I can draw a line like this, since it's moving on a straight line, right? And then afterwards, I can then say, okay, I'm going to start somewhere here. That's my origin, right? And then I'm going to start moving back and forth, right? Right. So that is when time equals to 0. Okay. So I'm at the origin and I start moving. All right. So let's see what happened here. Okay. So what happened here is, okay, at the first, like 4 second, all velocity is actually positive. So that means, okay, look, if you do a physics, you should know, right? The first thing you do is to define your positive direction, right? I'm saying to the right is positive. Okay, so what happened here is that, okay, so 0 to 2 seconds is simply move all the way. But you know that like S2 is 15, right? For the first 2 seconds, the distance is 15. Meaning what you can write is actually S2 equals to 15. Since it didn't trace back to itself, it didn't go backwards. So you'll be very sure that displacement in this case is the same as distance, right? So S2 is 15. In that case, that means like, let's say that's somewhere like 15 here. That would be when the particle is at 2 seconds. It start moving this way first, right? The particle start moving towards there. Let's say that's the particle, right? And then here, it keeps on traveling, right? Because look, the diagram here simply shows you that at the first 2 seconds, it first increases in speed. It is accelerating until it reaches a peak. It doesn't mean it goes the other way around yet. It simply means that it slows down afterwards, right? It's still going to the right. It's just that it slows down a little bit, right? So it's going to travel a little bit further until like somewhere here, which is t equals to 4, right? Because after t equals to 4, what happened to the particle? After t equals to 4, the velocity becomes a negative, meaning after this, the particle go backwards, right? The particle start bouncing back, right? It goes backwards. And then here's the thing, right? The clue here, that since you know that S2 equals to S5 equals to 15, of course, that means at the 5th second, it goes back to the same place it were. So actually, afterwards, at the 5th second, the particle go back to the same place it were, because the displacement at 2 and the displacement at 5 is the same. That means like the motion is going to be like this. It goes all the way to it goes all the way to 4, and of course, like during the motion in between, it speeds up and slows down at some point. But for now, that doesn't matter. And then it goes backwards and then passes through the same point the particle was at the 2nd second, at the 5th second, right? And then of course you can see that velocity remain negative, meaning it keeps going backwards afterwards, right? So that's the whole like essence of the question, right? Then we can finally look at what the question is asking for. So part A, so they ask you for S4 minus S2. What that really means is actually they are looking for that distance. Let me use blue. They are looking for this difference in that distance, this part here, okay? What I mean by that is because look, S4 is basically the displacement at the 4th second, which is exactly here. That's going to be S4. Let me just write it here. That's S4, right? And then S2 we already know is 15, right? But then how would you calculate this anyway? I mean, surely it's already given, because I hope you know, to calculate displacement, you simply integrate the velocity function, right? I mean, this you have to know, right? And if you're going from the 2nd second to the 4th second, what you're really doing is you're going from 2 to 4. That's how you get it, right? That means, this means the displacement from the 2nd second to the 4th second, which is exactly given by this expression. So yeah, it's given at 9. Very easy. It's already given, right? So that's it. And also in hindsight, you should know this, right? Because look, they didn't even give you the velocity function, right? Look, if like you don't even know what that function is, right? Like from the looks of it, it could be, I don't know, like it could be a modulation of a sine or cosine, or it could just be like some random polynomial, but it wasn't even given to you. That means you cannot actually do any proper integration here. That means you can only work it out from either a symmetry argument, or you can only work it out from the information that we're given. You are not probably required to do any actual integration, because there's nothing to integrate from, because you don't even know the velocity function, right? So yeah. Now part B. Okay, find the total distance traveled in the first 5 seconds. Now remember, they're looking for the total distance, not the total displacement, because if it was the total displacement, you would know it's 15 straight away, because S5 is 15. But total distance is a little bit different, because total distance is actually, you are looking for like the whole length of the journey. If it's displacement, all you care about is the start point and the end point. In this case, let me draw it out like a little bit clearer here. If the particles go from here and then it goes all the way back to here, okay, the displacement, all you care about is just that distance. It's the start point and the end point, right? But the distance is actually, you know, the whole journey, right? That is the distance, and that is the displacement. So you know this one is 15, but that's not that important for now. But the distance is the 5th second. So how do we calculate it? I mean, it's a 5 marker. Even though if you already knew it, you can see it straight away. It is just 15 plus 9 plus 9, which is going to give you 33. But okay, let's forget how I get this for now. Let's actually understand why that's the case. I mean, if you would like to get a 5 marker, I guess you would have to write some steps, right? You got to show, okay, I knew that to find the distance. There are 3 sections here, right? You can sort of thinking this as 3 sections. This is the first section. That's the first section. And then that is going to be the second section of the motion. And then of course, let me use some other color. This is going to be the 3rd section, right? Now, assume like the 5th second is somewhere like here. It doesn't really matter. Then that will be the 3rd section. And remember, you are not required to actually integrate it. So that's, I mean, if you do not know the function, that's fine, right? So that's how you would do it. So you would first write down, okay, therefore the distance, total distance, travel is just going to be, well, from 0 to 2 of the velocity function, dt, and plus from 2 to 4, v dt, and then of course the yellow motion, therefore you will given by from the 4th second, well, plus to the 5th second of the displacement, like that, right? So that is a 3 section of the motion that you might need to think about. The reason why I cut into this 3 section is, well, it's quite obvious why, right? Because you know that from the 0 to the 2nd second of the thing, it moved 15, right? So that's 15, right? That means like, now let me first actually erase this part here, so it'll be a little bit more clearer. What I want you to see is, look, the first section is actually categorized by that part. This is the first section. It first goes to this here at the 2nd second, so you know that's 15, right? And the second section is going to be from here all the way to the 4th second. And we have already calculated that, which is 9, right? So plus 9. And then the yellow section is simply like going backwards all the way to here. That's the 3rd section, right? Like going backwards. Then you can see if that has to be the same distance, right? So therefore it's also 9. So you can simply make this argument, then you're all done. And therefore the answer is just 15 plus 9 plus 9, which is 33. They did not give you any units. Actually, they did some meter. So that's really it. Yeah, so that's really not that hard. Yeah, you just really need to think about what's going on with the diagram and what's happening here. And you have to be able to make the argument here. Now, a very common mistake I've asked them to do is they would do something like this. They would do something like, okay, from 0 to 5 v dt, in hope of that's going to give them the distance. No, that is only going to give you the displacement. It will be a different answer, because if you simply integrate from 0 to 5, this yellow section here would become negative. So if you actually do that, if you actually just integrate from 0 to 5, what you're going to actually get is that you only get 15, because actually the 3rd section that you travel is exactly the same as the 2nd section. Because look at this diagram, right? If you go from the 2nd second to the 4th second to here, when you go back, surely that's the same distance, right? So that's also something to spot, right? So understanding this is actually not that bad of a question, and it's a very easy 7 marker, especially for the people who does physics. Question 8, let the function f be that, find the x-intercept of the function f. I think that's very straightforward. To find the x-intercept, what you do is you just equate that to 0, right? Basically, you're looking for these 2 points here and here, which is basically the solution, or the root of fx equals 0, right? So that means that's going to give you 9 minus x squared equals 0. So x squared equals to 9, x equals to plus or minus 3. Then you're done, right? Please do not miss out the plus and minus. I mean, you already know that's 2 points. So that means afterwards we can write 3 here and minus 3 here straight away. Okay, look, and then next, okay, now we finally get the function of the graph, and then they ask for, there's a rectangle, PQRS, drawn within P and Q on the x-axis, and the RS blah blah blah. Now let's not forget the function here, fx is 9 minus x squared, because that would definitely come in handy. Right, so what they ask for is the area. So that means, okay, look, to find the area of a rectangle is just base times height, right? Or whatever you call it, length times width. And you actually already know the width, right? That's 2b, right? If I were to draw the rectangle here, that rectangle you already know, because that is 2b, right? Because just 2b's, right? And then how do you find the height or the width of the rectangle? That means you're looking for you'll be looking to this point, right? This point, by the way, I hope you already know, is going to have a coordinate of b and something. And then I hope you will realize actually the y coordinate of this point, the s point is going to be the height, exactly the height, because the y coordinate is going to give you like the height of that point, right? So what you mean is what you need to do is simply find the y coordinate, or since you know that s is actually on the function, and remember this, right? If the point is on the function or on the line, you can always substitute the coordinate of the point into the function and it will always work. So in that case, it's very straightforward, right? So actually, this is actually just FB, like that, right? And then of course you can calculate it, right? So let me just do B here. FB equals to 9 minus B squared. So you know that like this here is 9 minus B squared, and you know that is also 9 minus B squared. Then in that case, you can just find the area, right? So therefore the area is simply 2b multiplied by 9 minus b squared. And a little bit of expansion, you should get that's 18b minus 2b cubed as expected. Now question C. Hence, find the value of b such that the area is a maximum. Straight away, I hope you are able to spot that this is going to be a differentiation problem. You are finding a maximum, right? So what that means is you're going to basically straight away differentiate it with respect to b and then equate that to 0, right? What you're going to do straight away is you are going to differentiate the area with respect to b. What that means is you're looking for the rate of change of the area in terms of b, right? And then that would therefore equal to 18 minus 6b squared. Now, if you're wondering why that happens, just know like normally differentiate with respect to x, right? This time we're just doing with respect to b. So that like now the b is your x, right? You got that and then you equate it to 0. The reason why you equate it to 0, remember you are looking for the maximum or minimum points, right? You're looking for the stationary points. And then afterwards, you can do a little bit of math. You should be able to get 3 equals to b squared. And therefore b is plus or minus root 3, right? That will give you an answer. And of course, straight away you would reject the negative because if you put negative back into your area, that's going to be a negative number, right? You can say since area of negative root 3 is negative, therefore reject, right? Because like area couldn't be negative, right? Therefore, you can say that b is therefore simply just root 3. One more thing you might want to do is to check, right? Because just because its differentiation is the derivative is 0, it could also be a minimum or it could be a point of inflection, right? So to check if it's a maximum, you do the second derivative test, right? So you would do d2a db squared. That actually give you just minus 12b. And then you would say, if I evaluate this at the point b equals to root 3, that would be minus 12 root 3, which is negative. Therefore, negative. Therefore, it's a maximum, right? So then you justify that it's a maximum. So then you're done, right? And so find the value of b. So that is simply just root 3, right? That means when b is root 3, you get the maximum area. Now, a little bit of looking back to the question, what does that really mean, okay? So you are looking in terms of b changing, right? Remember what happened when b changed. Imagine if b gets smaller. If b get a little bit smaller, let's say b is like somewhere here. Let's say that's b, right? Then your rectangle is going to get like taller, right? There. And that's your rectangle. So the idea of this question, that is b, that's minus b, right? The idea behind this question is, again, sort of like those kind of differentiation question where you have to find a maximum, is, look, you have a constraint, right? Because the smaller the b, the taller you get your rectangle. So again, you're looking for the combination, of b's, right? Such that you get a maximum area. Because if b is really big, right? Then you're going to get a really wide rectangle, but sacrificing the height. Now, if it decreases your b, you're going to get like less space, right? But you get a taller rectangle in return. So you're looking for what value of b would maximize the area. Should you sacrifice the height for the width, or should you do that the other way around? Of course, the answer is going to be somewhere in the middle. It's like an equilibrium, right? But that is the idea between why you can ask, what is the maximum value of area or blah, blah, blah. Right, so that would be part B. Now, you have another completely different function for some reason. So consider another function gx, right? Okay. And then show that when the graph of f and g intersect, blah equals blah. Now, okay, look, that should be automatic for now. Let me give me a second. Let me see how I can write it. Okay, look, can you still see? Yes, okay, so I think if I zoom into here, it is still, you can still see the question, right? So I'm going to do part D here. I'll use the other color as well. Part D is going to be here. Right. So yes. So now that we know gx is blah 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 and fx is blah blah blah, this by now you have to know you're going to be automatic, right? It has to be automatic because if you have two functions intersecting at a point, right, you equate the two functions straight away, right? Because look, fx is fx equals to 9 minus x squared, and gx equals to x minus 3 squared plus k. if they intersect, I hope by now really it has to be automatic, right? It's fx equals to gx. So 9 minus x squared equals to x minus 3 squared plus k. And a little bit of algebra, that should give you x squared minus 6x plus 9 plus k equals to 9 minus x squared. And of course, a little bit of algebra, it should really give you 2x squared. That goes there, and then minus 6x plus k equals 0. And yeah, exactly shown, right? Okay, now part E. Okay, and given that the graph of f and g intersect once only, look, again, this is like a no-brainer again. Like, you have to be automatic. Like something like intersect once only, or doesn't intersect, or intersect twice, and you are given a quadratic above, you know you're looking for a discriminant. You're looking for the amount of solution. Because remember, this thing here, okay, this thing here is going to give you the intercept of the two lines, right? Intercept of the lines, right? That means if you have two solutions, that means you're going to intersect twice. Now, if you only intersect once, you're looking for the fact that for that equation, the discriminant, or equals to b squared minus 4ac, will have to be exactly equal 0, right? Because bigger than 0, two solution, two intersect. If smaller than 0, just no intersection at all. And let me zoom up a little bit. I'll put it here. So then what you do is simply look at the thing, right? So b squared minus 4ac, so b is minus 6, right? B squared minus 4, a is 2, c is k, has to be equal to 0. And then you can simply do that's 36 minus 8k equals 0. K is therefore 36 over 8. Simplify. That's 9 over 2, right? And then you're done. Actually, I don't know why that's a 5 marker, because that seems very straightforward to me. Okay, question 9. A normal distribution question seems like very straightforward to me. And remember, since you are doing paper 1, you don't have a calculator. Most of the time, you are not likely to get asked to actually calculate, any proper, numbers. All right, like most of the time, like all of them will be given. You just need to spot for the symmetry of the diagram. And it's really like the question, like most of these questions in paper 1, is to go behind the logic of normal distribution of the z-score, and of course like the normal distribution of which area, what does that mean by each area, and also you'll be likely to recognize what is the the other area, just 1 minus the other area, that kind of thing. You're looking at the symmetry and of course like the complementary areas, right? You're very unlikely to ask to actually calculate some numbers out of the areas. You see what I mean later, right? Let's start it straight away. So 9a, okay, so you know that that's a random variable z. It's normally distributed with a mean of 0 and a standard deviation of 1. Now I hope this is strikingly obvious to you that if the mean is 0 and a standard deviation is 1, that is exactly the z-score. That is exactly the standard score. Because standard score is exactly defined by a normal distribution of mean 0, meaning right in the middle, and a standard deviation of 1. That is exactly what the standard score means. All right, that's textbook definition. And then the area behind minus 1.6 is a, and then blah 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 is b. So it's very straightforward. Now for part A, they ask you for the probability between the two areas, right? They're looking for the probability between minus 1.6 and 2.4. Now I hope you get what I mean. Like when I first started, by saying that for most of these questions, you just have to know that how to play around with the areas, right? Because now that you've learned for the middle ones, all you need to know, let me just draw it here to save some space. All you really need to know is the fact that is simply just 1 minus a minus b, right? Because area of underneath the whole curve is 1. If you take away a and then take away b, that is the area in the middle straight away, right? So you get what I mean by, most of these questions are usually just these kind of stuff. It could be a little bit complicated by introducing another variable and other distribution. But since you don't have a calculator, remember, most of the time you're only required to look for, in terms of area arguments or symmetry of the question. Right, and then, okay, part B. Given that z is bigger than 1.6, find a probability that is smaller than that. So okay, whenever you're dealing with this kind of probability question, please be very careful with the word given. Like the word given by now should be again very alarming to you. Whenever you're dealing with probability and you hear the word given, you know you're going to use your conditional probability, like this A given B. You're gonna have to like go for that thing, right? When you say given, you know it's going to be this, like somehow, right? And then look, what they're asking, given that is that, blah, blah, blah. So if I were you, I would just write it out first. Don't even think about it, just write it out. The probability that Z is smaller than 2.4, given that Z is bigger than minus 1.6. Now, for those of you who do not understand given properly, I don't want to explain too much here, but simply just know what's going on is that given that Z is bigger than minus 1.6. Now, remember before, our whole sample space was everything. So the whole probability was just 1, right? But now it's a little bit different. Given that it's already bigger than negative 1.6, your whole sample space suddenly just become this part. Let me sketch it out. This is your new sample space. Sample space, right? Because remember, like now that you are given that it is already bigger than 1.6, so you're disregarding the whole like the one before. Now that this is your new sample space, and what is the probability that is still there, right? So therefore, I mean, even if you don't want to think about it like this, you simply go straight away and do it, right? You can still use the formula, right? There's a probability that Z is smaller than 2.4, and then intersect with the probability that Z is bigger than minus 1.6 over the vector probability that Z is bigger than minus 1.6. So this is the textbook definition anyway, so you could still do it without understanding that part. Because if you understand that, the intersection part, which is simply just, you know, that area, which is the question you got before, the answer you got before, so 1 minus A minus B over, because 1 minus A minus B was exactly the middle part, right? So you're looking for what is the probability that it is that part, given that the new sample space is a little bit smaller, right? The new sample space is actually just 1 minus A, because that is just that, right? Because you're looking for the fact that given that is already not A, right? Like it's out of, you know, that part, how many part is still the blue part, right? So that's just that. Now part C, okay, part C is known that, okay, yes, exactly what I said, right? If they want to make it a little bit more complicated, they would just add in another variable, right? And then you have to find a way to convert between the two or spot the symmetry between the two, that kind of thing. So a second variable x is also randomly, it's also normally distributed with a mean of m and a standard deviation of s. So if you want to write it down, you do this, right? X is distributed normally with m and s squared, like that, right? Right, since no one tells you that x is actually a standard score, like we all know it's only like normally distributed, so there's no reason for me to draw in the middle, because that might not be the standardized score, right? So I can draw it somewhere like here, and then we know that the middle point, the mean, is m, right? And of course the s would be how wide the thing is. That would give you like, the s would determine how wide the curve is. Right, and then they tell you that, okay, p, you know, x smaller than 1 is a, so that means like that's 1 x, right? And then this area is a, and again, like you look at this, right? That means like if it's standardized, it would exactly be that score, right? Because both of the area is a, so if the variable x is standardized, 1 would turn into minus 1.6, right? So again, you do not need to do any calculation. You only need to spot that, right? So then straight away, right? Then you know that, you know, you can just, I think you can just write down minus 1.6, because I think that's so straightforward, right? Because yeah, you can see, right? Right, and then part D is a 6 marker, and we'll see what it is. So it's also known that p x then 2 is b. So okay, come on, man, like this is like stupid, right? So they tell you that, okay, there's another data point. Let me zoom out a little bit. There's another data point which is like 2, and they tell you, let me use another color, right? That means this is 2, here, that's 2, and this area is b, right? Then come on, man, like straight away, like that's 2.4. right? I mean, that's it. And then it asks you to find S. So right now you have two unknowns, right? M and S. That's your two unknowns. For this type of standard score question, it's quite straightforward. It's going to be a simultaneous equation. You were probably given two clues. In here you have two clues, right? One of the clues is this one. The other clue is that one. That links the x variable and the standardized score. And you have these two clues. You just have to form two equations and then do the simultaneous equation of it, right? Right, look. So then let's use the blue one first, right? You know that like 1, like the number 1 here, if it's standardized, it will be minus 1.6, right? So you simply use this formula here, right? The standard score is just the actual variable minus the mean over the standard deviation, right? Basically, you use this equation to form two equations, two unknowns, and you're done. So first clue is minus 1.6 is come from the fact that you have 1 minus the mean, which is m over s. So that is equation 1. Let me bracket it. Okay, that's 1. And the second one, use the second clue, right? It's the fact that, 2, like the number 2 and as x, right? If you standardize it, it becomes 2.4, right? So then you can just write 2.4 equals to 2 minus m over s. Then that's your second equation. And you can see, right, it's going to be exactly two equations, two unknowns, right? And then it's a simultaneous equation. Let me zoom a little bit. And then like solving it is rather like trivial because it's quite easy now, right? What you do, you're looking for s, right? So you want to eliminate mean, you eliminate m, right? So you're going to make m the subject and then equate them. So what you're going to do is minus 1.6 s would equal to 1 minus m, right? And therefore m equals to 1 plus 1.6 s. That's that. And then for the red one, you do something similar. 2.4 s equals to 2 minus m. M equals to 2 minus 2.4 s. Hold on. And then you simply equate the m's, right? So you would get 1 plus 1.6 s equals to 2 minus 2.4 s. And then with a little bit of calculation, you should get 4s equals to 1. So s is 1 over 4 or 0.25. Then you're done. All right, question 10. Well, not gonna lie, this does look a little bit scary. But I mean, this is the last question of the paper and also a 17 marker. So, I mean, it's only fair, right? So let's go and see what this question is about because like, okay, look, it looks very complicated, but regardless, maybe you can still get some mark out of this, right? And if we just work it out step by step, actually is not that bad, right? Now, question 10, they simply gave you, like there's a function f and gx, another function for which x is bigger than or equal to 0. The first time the f and g intersect is at x equals to 0. Now, I don't want to jump ahead, but then very nicely, they actually gave you the graph of f and g. Well, not exactly f and g because g is reflected. But yeah, you can sort of see it's going to be f and g later on. So I am actually going to use this graph as an example. So what happened here is that this graph is going to look like this, right? So if I were to actually draw g, now f is the oscillating one, right? That's f, okay? F is the one with the sign, right? So surely that's f, yeah? And then g is the other one, which is like probably, well, if I were to draw it now, it's quite hard, right? It's going to be something like that. All right. Well, I try my best. But that is g, okay? So that is going to be g, which is the reflected one, right? Because they actually tells you that the reflected one were drawn. So now, if anything, we draw the non-reflected one, right? But sure, let's start with here, right? So okay, look, they tell you that the first time that the two graphs intersect is as x equal to 0. Well, I mean, sure, because like exactly at the origin, I mean, both graphs started at the origin anyway. So for sure, that's the first time they intersect. Now, find the two smallest non-zero value of the next two intersection, right? I mean, like if fx equals to gx, what you're really looking for is actually just the next two intersection. I mean, yeah, so non-zero, because the first one is 0, so non-zero, of course, you're looking for the next two one, which actually is basically here and here. In that case, let me call this like the 0th time, okay? Reason why, it will come a little bit more apparent later. But yeah, like let's pretend that that doesn't exist, right? It's 0th time, and let's call that the first time, and let's call that the second time, right? Okay, yeah, so now we're going to find these 2 points. So surely let's actually go ahead and solve it, right? I mean, we can just do fx equals to gx and see what we get from, solving the equation. So fx is going to be root x sine of pi over 4, x equal gx is just root x. In that case, I mean, I hope you see what's going on, right? To solve this kind of sine equations, sine and cosine trigonometry equation, you always make it into just one single sine or cosine first, right? So sine of pi over 4 x just equals to root x over x, which is actually 1, right? So if you're confused about this kind of thing, these special angles, I would recommend just draw the sine graph straight away. Like draw the normal sine graph. That's a normal sine graph, right? Like that's y, x, and that's your sine x, right? That's your normal sine graph. And the first time it hit 1 is when it's like here, which is pi by 2, which is 90 degrees, right? And then of course, if you continue the graph, the second time it hit 1 is just going to be like after one more period, which is pi over 2 plus 2 pi, right? You add another 2 pi to it, right? 2 pi is 360, you're just looking for the next one. So in short, that would simply give you 5 pi by 2, right? I mean, you just do common denominator, that's what it is, right? So that means, very straightforward. And you can also see, right, if you just keep like continuing the graph, it's gonna keep hitting 1 like every like 2 pi's, right? Then that makes sense because you do indeed see that like the graph intersect at multiple different points, all of these different points, right? So you do expect that. But now that we're only looking for the next two, right? So we're only looking at this 2. So you get pi by 4x simply equals to, the first solution is pi by 2. And then the next one is 5 pi by 2. And then therefore, x is simply that divided by pi by 4. With a little bit of calculation, that is 2, right? And that would be 10, okay? Like, if you don't believe me, just go ahead and do, like, pause the video, do your normal division, you'll get the answer. And therefore, the next 2 smallest value of x is exactly that, then you're done with part A. So actually, part A is not that disgusting. It's 5 mark, but it's not that bad, right? And then part B, let me zoom into this graph here, just to illustrate the point. That means, what the 2 and 10 really means is, if you look at this here, let me zoom in more, it's the fact that like right here, this is 2, and this is 10, right? Like these are the points when they intersect, right? So like the fact that they're looking for the rest of these are the rest of the solutions, right? This is when x is 2, they hit x is 10. Then of course you can see that this keeps going on and on and on and on. Yeah, so that's why in part B they were saying like the set of all non-zero values, so discounting the first one. And now you see why that I count that 0th, because that's discounted, right? You don't count that. You start from the first being 2. All of these places where they intersect, turns out the x value form an arithmetic sequence. That's what they meant, right? And I hope you remember what an arithmetic sequence is. It's simply like a sequence of numbers in which they keep adding by the same number. Then in that case, if you know this is an arithmetic sequence, you can look, right? From 2 to 10, it's plus 8. That means to go to the next one is plus 8 again. So like you actually already know that the next time they intersect, x is going to be 18, right? And of course, the next one is going to plus 8 again, so 26 and blah, blah, blah. So that's why, I hope you see why I started with 0, because that is sort of discounted. You start your first time at 2, right? Yeah, so let me zoom out back to here. Yeah, so now that they tell you that it's going to be an arithmetic sequence, I mean, it's quite straightforward, right? You know the first term is 2, and then the next one is 10, and then of course the next one we already know is 18, right? So might as well just write 18 here. And then like they're looking for like a bunch of other stuff. It simply tells you like each of the consecutive points is just going to form the arithmetic sequence of plus 8 every time, right? Then now that they tell you that the arithmetic sequence is given by, you know, this general term, find the value of a and b, then simply we just have to remind ourselves, how do you find the general term of an of an arithmetic sequence, right? An arithmetic sequence could generally write by un equal to a plus n minus 1d. This you should know, right? And therefore, we know that the first term is 2, right? Yeah, because we start there. So we know that that's 2 plus n minus 1. The d is the common difference. Now we know it's plus 8 every time, so it's going to be 8 here. Then a little bit of rearranging, you get 2 plus 8n minus 8. So you can write that as 8n minus 6. And therefore, you could find the value of a and b, right? Then therefore, you would know that a is simply minus 6, and b, if you just compare the things, is 8, right? B, yeah, I wrote it like a little bit like in reverse, but it's the same thing, right? Like minus 6 would therefore be a, and then b is 8, right? So that's how you do part B. So again, not that bad. Yeah, let me just write it here as well, right? So a is therefore minus 6 and b is 8, okay? Right, and then we already got 9 mark, which is a relatively like straightforward, just sine, cosine, and then like trigonometry function, and then like a bit of AS, right? But the hardest part actually is to understand what it means, because I think a lot of students would have already got stuck at part B. They have no idea why out of nowhere there's an arithmetic sequence. But if I draw it out like this, I think it's a lot more clearer. Right, and our part C, so they say at point P, okay, point P is here. That's point P, okay? Yeah, because I think it zoom out too much, but all right. So at point P, the graph F and G intersect for the 21st time. Right, so what happened here is, look, 0, 1, 2, 3. Okay, yeah, you gotta be very careful here. Okay, you know you're looking for a term in the arithmetic sequence, right? I mean, if I were to like really like do it like dot, 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 like you're looking for that one here, right? It is a bit, you know, it's a bit tricky because, okay, I started with 0, so that it's easier for me to do part B, but you gotta always remember that the first time they actually intersect is at 0. Yeah, because like the reason why I started at 0 is because for part B, when we do an arithmetic sequence, you can start with your first term being 2. But in that case, you got to be very careful with part C, because yes, they tell you that they intersect for the 21st time, but including the first time that we excluded when they intersect at 0, actually, this is going to be just the 20th term in our arithmetic sequence, which is the U20. So this is actually rather tricky. It's very easy to get tracked up on this, because you might be thinking, once you got B, you got the AS, like the arithmetic sequence, you might go straight ahead and know, okay, now it's the 21st time, so you put in like the 21st term. But it's tricky. It's not that, because we don't forget, we actually have the first intersection in the 0th term, in the 0 there. So this is something that like you gotta be like beware of, you know, like be aware of the whole equation as you go along, right? So okay, you know what? Let me continue C here. Okay, so C. Yeah, so you look for U20, not 21, which is, again, I would have to admit, this is quite hard to spot. All right, unless you're keeping on track with the whole question for the whole time, which is often quite hard to do. So U20, okay, now they know U20, you just go ahead, right? Just 820 minus 6. This 154. Yeah, that means the x coordinate of P, so now you know, therefore, P is going to be 154 and something, right? That's what you have, right? Then how do you find that something? It's quite easy, because you already know that like P would go through like both like the function g and the function f, right? So you can substitute like 154 into either one of these functions. Of course you pick gx, right? If you put like into sine, that's quite annoying, but if you just put into gx, it's so much easier. So you look for g of 154. That will give you the y coordinate at that point, right? Which is going to be just square root of 154, giving you the point P, the coordinate of 154, and square root of 154. Okay, so actually this is a rather easy 4 mark. You just have to be able to spot. I think that the reason why it's 4 mark is very easy to get confused between the 20 term and 21st. But if you got that part, it should be quite easy. Now part D, right? So now that they tell you that, okay, there's an like, okay, look, they sketch out all the graph and everything, and then they ask you for the area of the shaded region. Now it would be very tempting to, you know, just go ahead and integrate, you know, like the function fx straight away, because okay, look, we're looking for the area, so you integrate straight away and then you plug out some bounds and this and that. Like, however, that's not gonna work. That is not going to work, because if you really think about it, this would only work if the whole graph is completely on top of the x-axis, because some of this part is negative, right? If some of this part is negative, like for this is negative part, right? Then the negative part will actually cancel with the positive part. So you can't just integrate straight away, because if you do integrate straight away, you're gonna get some negatives, and which will cancel out with. However, it's also not wise to, you know, separate into positive region and negative region to integrate, right? Because you might have learned, okay, sure, then we just do the positive part and do a negative part and put a minus. That is probably not that smart, because if you think about it, you have like what, 20 regions here. There's no way you separate them with 20, right? So what could you do? Now actually, if you think about it, you're finding the area between the function f, because the function f, remember, is a function that's oscillating, right? And also, let me yellow. Actually, there's a reason why they give you this line, like that line here, the function of. Now let me just draw it thicker. There's a reason why they gave you this line, the minus gx, right? The flip version of the g, right? It's because actually you're integrating the difference between the f and the g. Now I'm gonna be very careful just trying to sketch f as well, right? I'm gonna sketch a boundary of f. I hope that's okay. So f is like this, right? I'm gonna make it a little bit more clearer. So all right, okay, I'm just gonna sketch like one of these parts, right? Yeah, so what you're doing here really is you're looking for these regions, right? And I hope you see that these regions is given by the fact that you take the green line and then you subtract the yellow line instead of the x-axis. Therefore, you can't just integrate f straight away. You have to integrate between the two functions, right? So you have to do the green minus the yellow. Let me might as well finish the sketching, right? Because I hope now you see that, yeah, you're looking for the difference between the green and the yellow, right? If I were to draw it out like nicer here, you have the green and then you have the yellow like down there, right? You're looking for the difference between the two lines. So you have to do the green minus yellow. And then therefore you're actually integrating, and that's wrong, okay? You're actually integrating the function fx minus the yellow function minus gx. That and dx. And to think about the bound, we'll come to that later, but I hope you understand this idea first. You're actually looking for that. Then of course you're going to find the bound, right? But again, the bound is quite tricky, because you might be very tempted to go straight away and do, okay, surely we found p, right? So the bound is just the x coordinate of p. But not really, because if you zoom in enough, actually the bound is right here. It went past p, right? It actually goes down after p. If I draw on the line below, that was p, right? And then actually the graph go all the way until you go to the other side. So actually if you just do p, you'll be missing this whole region here, the whole red region here. I'm gonna try to sketch it here. You're gonna be missing like this whole part, that whole part there. Yeah, if I zoom in enough, you'll see. Hold on. So because p is actually just there, you will be missing the whole part here. So what that means is actually you will have to find, let me draw the axis as well, right? If that was the axis like right here. If I zoom in enough, that looks like this, right? Actually, therefore, you have to find the x coordinate of this point instead of p, or else you'll be missing a few things, right? So how to find that point? Then this is simply to do with the symmetry of sign, because if you think about it, right? P, now that you know P is that point, yeah, actually no, I'm going to use the point, like the graph below. If I continue this, that's going to reach another peak, right? And that is going to be the next point. So I hope you see that the point that you're looking for is actually the midpoint between P and the next peak, right? It's between P and the next peak. Now we already know that P is 154, right? Let me use blue. So we already know that this point right here is 154. Yeah. And then if you think about the idea of, the arithmetic sequence, right? If you think about it, the last point previously, that point was -8, right? Remember, it's +8 +8. So the last point there was actually 146, right? And then actually, therefore, the next point, the next peak is going to be that +8, which is 162, right? So now that you're actually looking for the value at the bottom, like the bottom peak, the bottom peak is actually like halfway between these two numbers, right? So therefore, that point is actually 154 plus 162 divided by 2, like the midpoint between the two, right? So that's why you actually have to justify this, right? Let me zoom out a little bit. You have to justify that. Of course, you start from 0, right? Give me a second. So of course you start with 0 because the whole graph starts at 0. But then the top part is actually the midpoint between 154 and 162, which is of course simply just 158. So integrate to 158. All right. Now this actually, like this part right here, the 158, is actually the hardest part of this question. To be able to spot this part, I think this is actually like the hardest part of the question. Yeah, but once you got that, once you understand this whole idea, the rest is actually quite easy because you simply substitute the function in and then you can just solve it. So let me finish it, all right? So we know that that's 1580. Function x, fx is just root x of sine pi over 4 x plus root x, right? So dx. Yeah, I think that's as far like as simplified as you can get. So that's done for the question. I mean, you can factorize the root x, but it doesn't really matter. Like that's good enough. Yeah, so I would say this is a rather tricky question from part C onward. But part A and part B is still an easy 9 mark. Part C, with a little bit of careful, be a little bit careful, you can actually get it as well. Part D is like the hard part actually, is to be able to spot the bound of 158, right? But once you got it, actually it's just a one-step question. But make sure you also justify the fact that y is 158.